Welcome to CSAI Think Tinker Learn. This is part of my System Design Essential series. The goal here is to give you a solid mental model of a system design topic. We're breaking down NoSQL categories today, demystifying document, key value, white column, and graph databases. This is a concept first introduction to help you build system design foundation quickly. If you want to see a deep dive on the trade-offs or a specific case study, let me know in the comments. No fluff, let's get into the technicals. You can find the full technical articles on my companion site. The link will be in the description. These videos or these episodic videos on the Essential series are deliberately kept short to provide a general framework. If you want a dedicated session on a specific internal math, just ask. Let's pull the engine apart now. To understand NoSQL, you have to forget the silver bullet mindset and start thinking in specialities. While relational SQL forces your data to fit a rigid schema, NoSQL bends the database to fit your specific access patterns. We categorize these by how they store data and how they handle relationships, whether you need raw speed, schema flexibility, massive scale writes, or complex relationship traversal. There is a specialized instrument for each of these jobs. First up, key value stores. These are blindingly fast and brutally simple. Think of it like a code check. You hand in a token, the key, and you get your code back, which is the value. The database doesn't inspect the contents. It just performs a direct address lookup. This yields over-time complexity. The sweet spot here is the ephemeral data, caching, active sessions, and rate limiting. This is where Redis shines, especially with its automatic TTL expiration. However, the simplicity of key value is also its greatest limitation. It is an opaque box. You cannot query by value. If you need to find all sessions older than 30 minutes, you can't just filter the data inside the box. The key is your only access point. If your access pattern requires filtering, sorting, or aggregating by attributes, a key value store alone will break your architecture. It's a specialized tool, not a general purpose one. Next is the document DB, famous for its Schema-on-Read. Under the hood, each document is entirely self-contained, usually as JSON or BSON. The superpower here is that you can store nested objects, arrays, and subdocuments in a single read without ever needing a join at a query time. This makes it perfect for fast-moving product teams who need to iterate on features without running complex database migrations every week. But DocumentDB comes with a classic dilemma: embed versus reference. If you embed a constantly growing array, like comments inside a post, you risk hitting the 16 MB BSON size limit and degrading performance. This is the unbounded array failure zone. The rule of thumb is embed if the data is small and always read together. Reference and store separately if the subdata is large, unbounded, or updated independently. For petabyte scale operational workloads, we look at wide column stores. These are row based, but each row has a dynamic set of columns. This allows for high sparsity, meaning there is absolutely no storage penalty for missing data or nulls. This is the architecture used by Apache Cassandra to handle massive IoT sensor streams and time series data where you have millions of rows but very different data points for each. The most critical decision in a wide column store is the partition key. A major failure alert is hot partition. If you group high volume writes by a single low cardinality key, like date equals today, you will flood a single node in your cluster while others just sit idle, effectively melting that node. In SQL, you normalize. In wide column, you denormalize aggressively. You design exclusively for your read patterns because cross-partition cluster scans are catastrophically expensive. When relationships are the most important part of your data, you need a graph DB. Unlike SQL, which joins tables, a graph DB traverses relationships via direct pointer dereference. Query time is O to the power degree. It is proportional only to the number of connected edges, not the total size of the database. Using the cipher query language, you can query or you can write queries that look exactly like the graph itself, making it incredibly efficient for pathfinding. Why not just stay with the SQL because of the join explosion? If you try to run deep relationship queries like friends or friends or friends, relational database face an exponential performance collapse, O n to the power n by m. If your query sounds like 6 degrees of Kevin Bacon, or if you are building social network or fraud detection system, you need a graph database like Neo4j to avoid structural performance death. Here's your decision matrix. Key value is for caching and sessions. Document is for user profiles and CMS flexibility. White column is for massive logs and time series at scale. Graph is for social networks and fraud detection. Understanding the weakness, like documents lack of deep joins or white column black or ad hoc queries, is what makes you a senior architect. Senior engineers rarely use just one database. We use polyglot persistence. In a hybrid architecture, your API gateway might route active sessions to Redis, user profiles to MongoDB, event audit log to Cassandra, and friend recommendation to Neo4j. Polyglot persistence means choosing the right specialized engine for each specific access pattern rather than forcing one database to do everything poorly. When you are in a system design interview, use this framework. Start with the shape of the data. Then look at the scale, millions versus billions. Then the consistency requirement, ACID versus eventual. And finally, the access pattern. Always ask, what are the top 3 queries this microservice must answer quickly before you even think about picking a database name? In NoSQL, we design the database around the query. To wrap up, remember the senior mindset. NoSQL is not a replacement for SQL. It is a toolkit of specialized instruments, each evolved to solve a problem the relational model cannot solve elegantly at scale. Now for the community. Have you ever migrated from SQL to NoSQL and realized too late that your access pattern actually needed relational joins? Share your migration regret stories in the comments. If you found this teardown helpful, please like, share, and subscribe to the CSAI Think Tank Learn. And do smash that notification icon so that next time we post any video, you get the notification. Check out the site for the full series, and I'll see you in the next one.